Thanks, Jeremy. Thanks. Well, thanks everybody for being here this morning. It was a lot colder out this morning on the walk over here than I expected, so hopefully everyone survived that frigid air. As Jeremy just mentioned, my name is Alex Naiman. I'm here representing the Exponent-led key team, which is composed of Exponent, also HID, and Gemalto. Most of you probably have not met me before. Brad McGoran is our project manager, but he couldn't be here this week due to prior commitments. He's hosting the NC B10 Smart Card Standard Committee meetings this week at our headquarters in Menlo Park. So I'm here today to talk about our NSTIC pilot, which we call the AuthentID system. And this is our plan to eliminate passwords via strong authentication methods. So I'm going to start by laying out sort of our vision for the system and the world of identity. But I want to preface this with a caveat that this vision, not everything in this vision is something that we're going to be implementing during the course of the NSTIC pilot, but this is where we see things going. So we start with Jane, meet Jane. Jane is a tech-savvy young professional who works at the Department of State, let's say. And Jane wakes up in the morning and puts on a watch which contains a secure element. This secure element is a container for a credential or credentials that she can use to identify herself to in the course of various transactions throughout her day. So as a first example, Jane picks up her smartphone. Smartphone is able to detect the secure element within the watch and prompts her to enter a PIN to unlock the phone. If she puts the phone down, removes the watch with the secure element from the vicinity of the phone will automatically lock. As another example, she can use her secure element contained in this wearable device to log into her laptop, perhaps prompting her for a different factor, maybe a biometric like a fingerprint to log into the laptop. Allowing her to use her machine. Oops, sorry. She's also able to access online services such as banking through additional authenticated transactions using the same secure element in her wearable device, the watch. Now, as I mentioned, Jane is a government employee, and she, retains a government employment ID, say a common access card or something like that, which she's still going to be using for physical access in her workplace. Also, maybe IT access in her workplace. So these are higher level of assurance uses, but lower level of assurance uses. Say transportation, she's able to use a credential derived from the government ID credential to access these services. And that derived credential also sits on the secure element on her wearable device. She can use an anonymous version of this credential to log into social media apps. And she's also able to do things like verify her age without divulging additional or PII to, say the store clerk where she wants to buy a bottle of wine. And so Jane, in our vision, is able to conveniently verify her identity, authenticate to various services, and all with the sound knowledge that she is protecting her identity. So now to introduce John. John is Jane's grandfather, say. He's not as tech savvy as Jane. He doesn't understand why Jane tells him not to write down his passwords and use the same passwords over and over on his various accounts. But luckily for John, Jane has bought him a bracelet with a secure element inside it, which he can use to authenticate in much the same way that she does with her watch. So John doesn't really have to think about protecting his usernames, passwords anymore, and doesn't really have to think about issues of security and identity authentication. Okay, so that's our vision. Now I'm going to talk about specifically what we're going to be doing in our pilot. So we'll be developing the following elements. The first is we'll be implementing a secure element, which can be integrated into one of two form factors, either a mobile phone or a wearable personal device, such as a watch or a bracelet, like I mentioned, Jane was using. We'll be developing a client, which allows the access and use of this identity credential, which is contained on the secure element. And we'll be implementing an authentication service to verify this credential and assert identity to various relying parties. So as I mentioned before, team members here are Exponent. We're the project lead. We're doing management of the project, evaluation of the systems. Our business is scientific and engineering consulting. We do have a lot of work on standards evaluation, testing, failure analysis, that sort of thing. HID and Gemalto are pretty well-known names in this business, and they will be doing most of the implementation on the technical side of things, and hopefully, we hope, building interesting businesses going forward around these technologies. We have three relying party pilot partners. The DoD, specifically the DMDC, a leading social media company, and a healthcare provider. And both of those partners are confidential at this point. We also have two supporting partners, Stanford Computer Science Department and Experian. So I'm not going to go through this in too much detail, but I want to just sort of highlight, how we are hitting each of the NSTIC guiding principles. So we feel, and we are focusing on privacy enhancing and voluntary elements here. Our system will provide granular and interactive user control over data to provide privacy enhancement. We're separating the IDP and relying party roles to provide additional privacy enhancement. Replacing, under secure and resilient principle, we are replacing passwords with a more secure credential, in some cases two-factor credential. And I'll talk a little bit more about this opacity protocol. This is an interesting secure and privacy enhancing protocol that we'll be using in our pilot to provide security for contactless transactions in particular. Our system is going to be based on SAML global platform ANSI standards, so we'll be ensuring that the system is meets the standards that we are attempting to follow. And we'll be enabling both citizen to business and citizen government interaction transactions. One of the big focuses for our project is this idea of a user-friendly, convenient device, for example, the wearable device, and that's we feel is one of the stronger points of our pilot. So I want to walk very briefly through sort of the system architecture that we're talking about here. So a user who wants to be issued a credential to store on their wearable device. So the wearable device is pictured here, but you could also imagine that that's a mobile phone. They'll visit an enrollment portal to request a credential from this IDP. The IDP may issue a proofing challenge, which the user will have to use to prove their identity. Once the proofing challenge is successfully responded to, the IDP will issue a command to the wearable or the mobile to secure element to generate a key pair, of which the private key is stored there on the device. Public key is returned over the network to the IDP. So this is a typical PKI sort of a setup. To authenticate to a particular relying party, the user will go to the relying party, say through a browser. The relying party will ask the user to identify themselves through a supported IDP. Redirecting to that IDP. The IDP will verify the authenticity of the secure element that's requesting the authentication and forward a SAML assertion or other assertion to the relying party through the user's client in order to verify their identity for, say, login. So two of the concepts, two of the elements I want to just mention again briefly here that we're leveraging. The first is GICS, which is an ANSI standard. It's a generic command set that will operate on the secure element and allows widespread interoperability of these elements. And opacity, opacity is a part of GICS, but opacity is a contactless protocol for contactless transactions. And I'll talk about these a little bit more here. So GICS stands for the Generic Identity Command Set. And again, it's a generic interface. It's a set of commands that will run on the secure element, allowing credentials to be stored on that secure element in a standard way. So again, this is an ANSI standard. It's been in development for the past 4 years, and our team members have been heavily involved in the creation of this standard. Opacity, which is a terrible acronym that I'm not even going to attempt to run through, is a very interesting protocol for doing fast contactless communication. So the need that was identified here was for a faster, secure contactless protocol to allow things like access control, where you need to do that transaction quickly so that the user doesn't become frustrated that the door hasn't opened yet for them. And so this opens contactless cards for use in many applications. Okay, so I mentioned we have 3 relying party partners. Again, the first is the Department of Defense, and our pilot there will be demonstrating derived credentials with DMDC. Our second partner is a social media company, for which we'll be demonstrating strong authentication using our portable identity credential. And the third one is a healthcare provider. And similarly, we'll be demonstrating strong portable credentials for doctors. So just to dive into the government pilot a little bit more, the vision for this pilot, the use case, is enabling users to access online services using a credential derived from an existing CAC credential, probably CAC, onto a mobile device. So the sub-bullets there under considerations, these are more like challenges that we're facing and we're aware of and we're working through right now. There's a lot of uncertainty surrounding derived credential usage, and this is something that we're working to understand right now, with the hope that lessons learned from this pilot will hopefully help resolve some of that uncertainty and provide lessons learned to the community working on derived credentials. We've talked a little bit about user experience challenges that we're gonna face here. How are the ergonomics of using your CAC to identify with your phone? How's that going to work together? Some battery life considerations. For the social media partner, we'll be enabling user login to a social media service using this PKI credential stored in a mobile phone. Challenges for this one that we've already been working through. We've come across this conflict between the business model of our social media partner and some of the goals and requirements of NSTIC. And I'm sure we're not the only pilot to have come across this sort of problem. The third partner, we will be enabling, not sure why it says doctors/patients. We're actually just looking at doctors right now to log into office terminals using, again, this PKI credential that's stored in their convenient wearable device. So this is where the wearable will come in. Challenges for this particular application that we are talking to our partner about are tying into their proprietary EHR system, which is not necessarily a straightforward activity. So just to close out here, I want to give it a very brief description of our schedule. We're well into the planning phase of this project. As you can see, we're about halfway through our specification for the system planning phase. So we have a lot of work still to do on defining exactly how the system is going to work. We're working with our pilot partners to define requirements for the pilots. And again, that's very much a work in progress. The target here is to do deployment of our pilots with our partners in the second year of this project. Just to conclude, we're focused on the system that provides Jane and John with this NSTIC vision of the world. We're very excited to develop these 3 pilots and provide lessons that we learned to the NSTIC community and the larger IDESG. Thanks.